This video is about specific heat capacity and specific latent heat calculations. This will involve one-step, two-step and multi-step calculations. I've divided this video into two parts. In part 1, we will just look at one-step calculations of specific latent heat. As we've already done one-step calculations with specific heat capacity. The starter is a quick warmer up about internal energy. I'd like you to answer as many of the questions as on the next slide in 5 minutes, and then use the following two sides to check your answers. You only really need to draw or write anything for the last question. Here is the starter. It's basically just a factual recall about internal energy. These are all really short answer questions, apart from number 6 where you've got a sketch. Good luck, everybody. Here are the answers. Question 1. The internal energy is the total energy of the particles in terms of their kinetic and potential energy. Question 2. How can you transfer energy into the system? By heating. The changes which you're looking for. You've got freezing, melting, boiling or evaporating, condensing, and this idea of subliming where you go straight from a solid to a gas or a gas to a solid. A physical change, you don't end up with a new substance. Same substance you started with, just in a different state of matter. Question 5. Yes, change of state does conserve mass because there is no change in mass. You have the same amount of substance at the start and at the end. And question 6 on the next slide. Just look at the diagram of a heating curve. Make sure you have the heating rising. Latent heat calculations. Now the most important thing is to decide if it is a latent heat. And you will tell that from the question, because it will be about change of state. There will be nothing about temperature change. That is due to specific heat capacity. Now the question you're given here, the specific latent heat of vaporization of water is 2,260,000 joules per kilogram, and you're using 1.5 kilograms of water. You are being asked to calculate how much energy is needed to boil this water. It's most important you adopt this method. So the first thing is quote the equation. Energy equals mass times latent heat. Second thing is to substitute your values into it. So the mass is 1.5, the latent heat is 2,260,000. The third step then is to calculate, which comes out as 3,390,000 joules, and fourth step is to add the unit joules. These are two questions for you to practice using the specific latent heat equation. Make sure you lay them out in the method that I showed you in the previous way, which is formula, substitute, calculate. Number 1, the only thing to be careful with is the mass units. Number 2, you have to do a rearrangement to make mass the subject of the equation. The next slide will show you the worked examples and the answers. Good luck. Here are the answers with working, so you can check first of all you've got the correct answer, and two, if you haven't, by looking at the method you can see where you made any errors. Please correct any errors.